a career in the military intelligence services before the war. And then he came to Ohio State in 1947, where he got his PhD. And then he went off to have a very storied career at the University of Wisconsin-Madison. Professor Robinson is, of course, well known for his eponymous map projection, which he invented in 1961, the Robinson projection, which is, it's not a conformal map and it's not an equal area map. It is not even a map that's based on math. In fact, he had this famous quip where he said, quote, in the New York Times in 1988, he said, quote, "I decided to go about it backwards. I started with a kind of artistic approach. I visualized the best looking shapes and sizes, and then I figured out the mathematical formula to produce that effect." And then when addressing his competitor projection, which was the Peters projection, he said that the land masses looked like wet, ragged, long winter underwear hung out to dry on the Arctic Circle. So Robinson clearly sounded like an energetic and interesting fellow. I was going to say that qualitatively minded PhD students should take note. This was a very successful subjugation of math, because his map projection was the official projection of the National Geographic starting in 1988. At any rate, the Arthur H. Robinson Fund was established in 1985. And as part of that very generous fund, we are able to have an Arthur H. Robinson colloquium, which in fact he himself kicked off in 1997. And we have had a range of very well-known scholars which have addressed us under the Robinson banner. And this afternoon, we are very pleased to have Dr. Marshall Shepard with us as our distinguished Robinson speaker. Thank you so much for joining us. And I do want to thank you in particular for taking time out before the talk to interact with our grad students. I understand that was really appreciated. And I'm going to pass things off to Professor Ellen Mosley Thompson for a formal introduction. Thank you.
All right. Thank you, Matt. So I'll just give a brief introduction. So Dr. J. Marshall Shepard is the Georgia Athletic Association Distinguished Professor of Geography and Atmospheric Sciences at the University of Georgia. He also serves as the director of the university's Atmospheric Sciences program. He received his PhD in physical meteorology from Florida State University's Department of Meteorology, and he spent 12 years as a research meteorologist at NASA's Goddard Space Flight Center. And during that time, he served as the Deputy Project Director for the Global Precipitation Measurement Mission. Dr. Shepard is highly sought by many professional organizations and public media outlets to speak regarding climate and weather. In 2013, he served as the president of the American Meteorological Society, of which he is an elected fellow. Dr. Shepard has authored or co-authored several books, including a children's book on weather and weather instruments called Dr. Fred's Weather Watch. In 2020, he published The Race Awakening of 2020, a 6-step guide to moving forward. For those of you who, like me, frequently watch the Weather Channel, you will have seen Dr. Shepard hosting Weather Geeks, which is a pioneering, award-winning TV talk show and podcast. If you haven't seen it, it's a hoot. I really enjoy it. I'll always look forward to it. Dr. Shepard is an elected member of the National Academy of Sciences, the National Academy of Engineering, and the American Academy of Arts and Sciences. So let's get started, and we'll get your slides up. And join me, audience, in welcoming Dr. Marshall Shepard, who's going to present the extreme weather climate gap, the intersection of extremes, vulnerability, and risk. And Marshall, thank you for joining us today. So we'll get your slides up.
Thank you so much, Ellen, for having me, and I look forward to interacting and speaking with you today. It's really an honor. So I'll get my slides going here, and then we will dive right in. So hopefully you can see my slides at this point. Is that Do you see a hurricane in my introductory slides? Great. So it's really an honor to be here again at The Ohio State, if not this time virtually. I'm going to try to reduce some of my, try to reduce that on the side. There we go. I was able to visit with you in person over 10 or so years ago. I don't actually remember the date and time, but I did have one visit there to the Ohio State University, and it's an honor to be invited to deliver the Arthur Robinson Colloquium talk. I did do a little research and was quite an innovative scholar in his own right, but also seemed to understand the sort of challenges and nuances of conveying scholarship in a way that was accessible, either through his words or also through his cartographic work. So it's really an honor. The title of today's talk is The Weather Climate Gap, the Intersection of Extremes, Vulnerability, and Risk. And this is a blend of many things that I have been thinking about from a scholarly research perspective, as well as from a broader reaching perspective as well. If you are on Twitter, I invite you to follow me at Dr. Shepard 2013. Feel free to tweet anything that I may say today and otherwise, because as I was telling some of the graduate students earlier, I don't like to keep our knowledge in the ivory tower. I need for it to be more broadly distributed. And so feel free to engage as well in this talk, because I actually like for those talks to be publicly discussed as I'm giving them. So what you see in this graphic is a satellite image of Hurricane Ian, powerful hurricane, Category 4, that made landfall just recently in parts of Southwest Florida. That will be the context for the beginning of my talk. This is another satellite view. I wanted to start with maps and map projections, given the historical context for the colloquium series that I'm speaking within. And this is one of the more interesting perspectives on Hurricane Ian that I see. And it really synthesizes who I am as a scholar and a researcher. Because if you followed my scholarly line of research, I've done work on urban climate, hurricanes, extreme rainfall, and other types of weather events. And this particular satellite image captures all of that. We see Hurricane Ian. We see the nights at light from a satellite perspective, representing many urban spaces in the North American continent. We also see, if you look carefully out in the Pacific Northwest and just off the coast, a very large polar low storm as well over in this region here. And so the natural and human intersections are apparent even in this map. But as we come to the human connectivity, here is the HCA Florida Fawcett Hospital in Port Charlotte, Florida, on Wednesday, September 28th. Clearly underwater, flooded because of Hurricane Ian. This is an infrastructure challenge that we are seeing in many parts of the United States that experience hurricanes. We don't have to go back too far to see another example. This is the Bay Medical Center Sacred Heart in the Panhandle of Florida. And as you recall, 2018, Hurricane Michael, a powerful Category 5 storm that rapidly intensified, moved into parts of the Panhandle of Florida and destroyed much of Panama City and Mexico Beach, Florida, and then actually moved into Georgia, my state, still with 100-mile-per-hour wind gusts, and destroyed much of our agricultural community's output for that year: peanuts, cotton, poultry, and so forth. And that had a ripple effect throughout the country, because Georgia is a leading producer of things like peanuts and cotton and pecan and so forth. So when you went to your local grocery store to buy a jar of peanut butter or a t-shirt made from cotton, you may have been paying a bit more for it because of that. And so again, that interconnectivity between the natural and the human dimension, which is inherently what we as geographers and geography departments do, is manifested at times by these weather extremes. Another example of sort of the intersection of the human dimension and a natural disaster or weather-related disaster. I don't like to really call them natural disasters anymore because hurricanes are natural, but we build things in front of them. And so in that regard, they may not necessarily be inherently and purely natural in that sense of the word, but you can see August and then after Hurricane Maria, power outages because of Hurricane Maria and the various ways that that storm impacted that island. And I believe Steve Quiring's still there in your department. He certainly is pioneering methods to assess power outages and infrastructure as it relates to severe events like this or extreme events like this. So shout out to Steve Quiring if he's there. It's not just hurricanes, though. This is a really compelling story about infrastructure and the evacuation of a hospital in Santa Rosa, California, in the midst of a wildfire in 2017. And these were two of the key principal executives involved in those decisions as it relates to evacuation. I like to keep an eye on things. I see Steve is there. So occasionally you will see me pause and look at the comments there. So I do kind of keep track of these in real time when I give virtual talks. So feel free, to chime in there as well. It's not just infrastructure though, and this really starts to move in the direction of what I want to talk about today. And I think, again, understanding the context of this particular name colloquium and being a geography department, I will really blur the lines between climate and social vulnerability and cartographic techniques, maps, satellite techniques, and so forth. But here's a human dimension. After Hurricane Ian hit Fort Myers, Black neighborhoods say that they aren't counting on much help. And this is at the core of this weather climate gap that I introduced in the title of my talk and that I will discuss with greater detail as we move forward. And I imagine that some of our colleagues that really focus on sort of human geography and political ecology and environmental justice will resonate with some of the discussion that I will present today. So let's set the context, and I won't have to spend much time on that with this particular audience. If I'm talking to Congress or a Rotary Club or someone else, I might have to really make this case and drive it home. But I think this particular audience understands that our climate is changing, and we are likely seeing that in the manifestation of extremes. This is the 2021 billion-dollar-plus weather climate disasters in the United States last year, and there were 20 of them. And again, some of these were well over $1 billion in damages. I was just mentioning before I came on, if you watch Netflix, I am in a new series that debuted on Netflix yesterday called Earthstorm. And one of the series, in fact, the one that I'm in focuses on Hurricane Ida, which you see here. We break down Ida from many different perspectives in that docuseries on Netflix. So check out Earthstorm. It's a jaw-dropping look at Hurricane Ida, and the other episodes are on tornadoes, volcanoes, and earthquakes, so as well. But again, as we move to 2022, we're not even through the year yet, and we already have 15 events that have produced over $1 billion, and in some cases far more than $1 billion. I can't even imagine what the number is going to be for Hurricane Ian, but I would predict well over $150 billion in damage. And I'm using other reference points to arrive at that number. So we know from a disaster standpoint, from a cost standpoint, this is likely a manifestation of the shift in extremes. So our climate is changing. I think we have moved beyond the narrative of convincing people otherwise. I think people do get it. Yeah, there are small pockets of contrarianism. It's about 7 to 8%, according to the Six America study that Yale Climate Communication Group does each year. So my message there is don't spend a lot of your time getting bogged down with that 7 or 8%. They're the loudest, but they don't necessarily represent the prevailing perspective that's out there on climate. So we really don't have to deal with that side of the equation. Now, we are in what many call a period of climate delayism. The White House convened a group of experts earlier this year. I was one of those. And we were discussing with White House officials how we move the needle forward on this idea of climate delayism, which is, yes, something's happening, but now the debate is more about what to do and how much it costs. And in reality, it's always been a little of that, but I think that there's an acute sense that climate delayism may be bogging us down now. But that's a different talk for a different day. Well, let's look at this little anomaly. I am a climate scientist. I've got to show some data. This is just really an interesting way to show how temperature anomalies have changed from, over the last several decades. And so what it will tend to see is this shift in the distribution, towards warmer anomalies as we get into present time. So what was a heat wave in the 1950s is now the average or the median of the distribution, if you look at that carefully. And the extreme tail that we see is sliding to the right. So that means we're seeing a distribution or skewing towards more extreme frequent heat waves. The other side of this ledger that is of concern and doesn't necessarily get the attention that it deserves is the left side, because what that means is our minimum temperatures are also warming, and that has serious implications for health when we see these heat waves in Europe and in the United States, because it's the nighttime temperatures, if they stay elevated, which create the greatest risk for health or mortality issues. And so this is a very powerful distribution that makes the point scientifically. But let me make the point from a so what common sense perspective. This is a graphic from the National Climate Assessment that shows the change in hours worked by outdoor workers as we get to more extreme heat regimes. We know that OSHA, Occupational Safety and Health Administration or agency, has requirements in terms of wet bulb globe temperatures and other things sort of thresholds that allow people to work outside. So whereas this was really something that I would talk about at the AGU or the AMS or the AAG, this is what I talk about when I go to a local chamber of commerce or to someone that doesn't necessarily have a bunch of letters behind their name that have MS or PhD, because this is the so what. This affects economy, this affects people's lives and so forth. Here's a look at sort of the places in the United States that will suffer most in terms of GDP by the year 2080 or 2090. You can see your region of the world, Ohio, is certainly represented. Here in the South, we are in a sweet spot. Certainly you see impacts as well in Ohio, but here in the South, where we already experience every single type of extreme weather event imaginable, whether it's tornadoes, hurricanes, heat waves, snow events, rainfall, and so forth, there certainly are some areas of vulnerability, and I'll speak a little bit more on that in a moment based on some of our own research. More examples of so what, in terms of environmental degradation, degraded living conditions, vector diseases, water and food supply. I'm showing this because as I was talking about with your graduate students earlier, we have to communicate, we have to meet people where they are on climate in order to move the needle. We can't just get bogged down in our scholarly jargon on trend lines and sensitivity analysis and so forth. These are the things that resonate most with people, I've found. Which brings me to 2019, when I sat before the House Science Committee in Congress and talked about the fact that extremes are becoming more extreme, and that's what people notice. People notice a Hurricane Ian, or they notice a once-in-a-generation heat wave, or an extreme flooding event like we saw in New York City after Hurricane Ida last year. So we know that our extremes are becoming more extreme. So the answer to this fundamental question, is the DNA of climate change already in today's weather? Well, it absolutely is. I just mentioned Hurricane Ida. This is an image of flooded roadways in New York City as Ida moved into the Northeast. Many people were trapped in basement apartments and that were flooded because of torrential rain. I think there were 3 inches of rainfall in 1 hour in Central Park, which was a new record. And just from a scientific perspective, this is just one manifestation. As our climate system warms, there's more water vapor available to the atmosphere, and that water vapor is essentially the fuel for these rainstorms, these hurricane rains, perhaps even snowstorms. And so that's basic. That's not politics. That's not controversial. It's physics. It's the Clausius-Clapeyron relationship. And so we know that the extremes are changing. In fact, I co-authored this report, Attribution of Extreme Weather Events in the Context of Climate Change. We wrote this report for the National Academies in 2016, and we found that we have strong ability to attribute certain events to climate change, heat waves, drought, extreme rain events, aspects of hurricanes, and so forth. I like to use this little analogy. We use this analogy to sort of canvass Congress on some of the results of that report. So, bizarrely and surprisingly, I still get people that come up to me, an atmospheric scientist with quite a few degrees in this topic, and they'll remind me that climate changes naturally. And I say bizarrely because it would be pretty strange of me to have been awarded a PhD, a master's, and a bachelor's degree from Florida State without knowing that. We certainly know that climate changes naturally. But this little analogy with the cookies shows us that we can certainly have naturally varying occurrences. We can have different ingredients that might produce a different cookie or a different hurricane, depending on how you change the ingredients. Well, hurricanes have different shapes and forms and intensities and so forth as well. But nowadays, they're forming within the context of a warmer climate system, of a warmer ocean heat content, of changing sort of upper level atmospheric patterns and so forth. And so this is what I'm trying to convey with this little cookie analogy. And so if we know that the extreme events are changing, and we do have pretty good evidence of that in the peer-reviewed literature through attribution studies, I think about things now in terms of risk. And again, this is presented in the IPCC and other formats. This little equation I want to sort of zero in on because it kind of captures the essence of this graphic. We can think of risk as some function of hazard, exposure, vulnerability, and resilience. Well, hazard is the actual event, the drought, the hurricane, the flood. Exposure is how are we, meaning people or infrastructure, exposed to the hazard. And then we have to think about the vulnerability or sensitivity to that exposure. And we know that there are certain people, and I'll talk about them in a moment, that are disproportionately sensitive to that exposure. And then the last term is resilience or adaptive capacity. Some people, though they may be exposed to the hazard and have vulnerability to it, are able to bounce back. They have the ability to recover. And that's what we refer to as resilience. And so when we combine those, we come together and understand that there's risk. So this is a paper that we published last year. We were trying to project the climate vulnerability and risk at county level for every county in the United States by the year 2040. This is work of my former doctoral student, Dr. Benita K.C., who's now at NASA Goddard Space Flight Center as a data scientist. And you might look at this immediately and say, oh, wow, we're in the clear here in Ohio. It's yellow mostly. Well, this is a skewed scale deliberately. Yellow counties are still vulnerable, but the blue, purplish, brownish, those are highly skewed to the right. We designed this index in a way as to be a red flag, to be a warning, flashing yellow, red light, that those counties are the ones that are particularly vulnerable by 2040. And so what you see is many of our coastal communities and counties, many of our urban counties, the desert Southwest, parts of the Pacific Northwest, emerge as the most vulnerable counties. Now, clearly, as we look in Ohio, I bet I can pick out some urban spaces in Ohio that would represent and reflect some of that vulnerability. Now, why that's of interest to this particular talk is many of the people that live in some of these counties represent high levels of vulnerability and sensitivity, and we'll discuss that in more detail momentarily. So the National Climate Assessment, this is where the 2018 report, and we have the 2022 report forthcoming soon, identifies 4 groups as particularly sensitive or vulnerable to these extremes: communities of color, children, low-income communities, and older adults. So, for example, communities of color are more likely to face cumulative exposure to multiple pollutants. Older adults are vulnerable to extreme heat events that cause power outages and require evacuation, the type of thing that I mentioned earlier, and that's why I know Steve Quiring's work is so important. Low-income communities are at risk of physical and mental illness during flooding or in crowded shelter situations. These are just sort of specific examples of that vulnerability that I talked about in that risk equation earlier. So now let me sort of frame what I mean by extreme weather climate gap or climate justice. But first, let me start with environmental justice, because oftentimes people lump these together, and I think they're different. Environmental justice, let's look at this, what Robert Bullard, a good colleague and friend of mine, who is considered the father of the modern environmental justice movement. He said, today's zip code is still the most potent predictor of an individual's health and well-being. Individuals who physically live on the wrong side of the tracks are subjected to elevated environmental health threats and more than their fair share of preventable diseases. So when he's saying this, he's really in many ways talking about situations where you have industrial activity, waste fields, landfills, and so forth, placed in lower economic and communities of colors. And so they are disproportionately exposed to toxic hazards and other conditions that would lead to health-related threats and so forth. That's really the essence of environmental justice. When I think about climate justice, or what I like to call the weather-climate gap, it really is this disproportionate sensitivity to extreme weather and climate events and a delay in the ability to bounce back. And I want to give you a couple of examples of this. This first one is from a book chapter that we just published, myself, Steve Holloway, and Jerry Shannon. So a climatologist, an urban geographer, and a GIS expert. That's the beauty of geography, by the way. I wouldn't have been able to do that in a standalone meteorology department like I came out of as a scholar. So we took NASA MODIS data and we mapped over this almost 20-year period what the surface or skin temperature urban heat island looks like around the metro Atlanta area. And so you can clearly see the heat island of Atlanta. But we then looked at some of Steve's data and we found that when we break that out by race, many of the hottest parts of the city are where communities of color are. And we dug a little bit deeper with one of his students, Scott Markley, and we find that many of these heat islands within the heat island, what we call racialized urban heat islands in the chapter, are very much tied to historical redlining patterns of past decades. This idea that mortgage lenders and banks would redline certain parts of maps that they would then not issue loans or access to housing to certain communities. Over time, those redlined areas have disproportionately become more industrialized, less vegetated, and more likely to exhibit characteristics of the urban heat island. So these racialized urban heat islands are not by accident by any means. So this is an example of this disproportionate sensitivity. To not come across as just all doom and gloom, because I am a half full kind of glass half full kind of guy. I got together with some engineers at Georgia Tech, some scholars at Arizona State, and some colleagues at North Carolina A&T. And over the last several years, we've been working on this concept. I came up with this idea of what we call thermal justice. And we asked the question, can we actually engineer cities for thermal justice? So this is a thermal injustice. So can we engineer the cities for thermal justice? And so we proposed to the National Science Foundation, ERC, and to a recent DOE call we have some radical and innovative ways that we want to engineer cities using microgrids and low thermal impact PV and adaptive pavements, like chameleon type pavements and so forth, to repurpose, redistribute, or reutilize that excess heat that the city itself produces. So again, this is going well beyond planting trees or high reflective albedo pavements. This is a fundamentally different way of thinking about how we engineer cities to eradicate that thermal injustice evident in this map. Another example of the extreme weather climate gap, this is data from the National Climate Assessment that shows the increases around the country, except the Southwest, in the heaviest rain events. So the top 1% to 2% rain events in terms of intensity. We see increases all over the place. Well, where's the weather climate gap in that? Well, my former PhD student, Dr. Neil Debich, who's now at the University of Texas, San Antonio, published a paper in Anthropocene just a couple of years ago that showed in the Atlanta to Charlotte corridor, what we call Charlanta, African Americans are 40% more likely to live in flood zones in that I-85 corridor from Atlanta to Charlotte. And in his paper, he also showed that in the Greenville-Spartanburg area, African Americans are 80% more likely to live in 500-year flood zones. So just another example of the extreme weather climate gap. So when we see headlines like this, a year after Hurricane Harvey, Houston's poorest neighborhoods are slowest to recover, I'm not surprised. I mean, I've been in New Orleans, Louisiana recently, and I can still see the scars of Hurricane Katrina, which happened in the year 2005. And it relates back to the gap. And I wish there was an elegant solution, an elegant explanation that I could sort of attribute it to, but it's really a simple one. It really is. It's related to the racial wealth inequality. So give you an example. I mean, if I were on the coast and a hurricane was approaching, I have the means to take my family and drive inland to Atlanta or Memphis and stay in a Holiday Inn Express or wherever, and get out of harm's way. I know that I have insurance in my home if my home is damaged by that storm or destroyed even. That is not even on the table for many people in these communities. When we look at Hurricane Ian, there were people in parts of Lee County and Fort Myers that, yeah, they probably wanted to evacuate, but it wasn't trivial for them to take their family and drive 800 miles and get in a hotel. Or they may have been living in, situations like, Neil found in his work where they're already living in vulnerable flood-prone areas because they have a certain income level, a certain socioeconomic or demographic status. And so they were in some of the sort of cheaper land, flood-prone land. These things are all connected. So at the end of the day, the racial wealth inequality in this country, as you see here in this graphic, very much describes the extreme weather climate gap. So I wanted to share this because this is something that I'm involved in right now. I am actually a part of a National Academy study with the Gulf Research Program. The Gulf Research Program is part of the National Academies, and they have stood up a consensus study that is trying to look at compound disasters in Gulf Coast communities over the past 2 years. What's a compound disaster? Well, in this context, it's the fact that that community from Texas over to Florida dealt with 2 record-breaking hurricane seasons, significant tornado outbreaks, and the winter outbreak associated with the sort of polar vortex intrusion of cold air a couple of years ago in the midst of a pandemic. So these compound disasters. Now, you can look at compound disasters in several different ways. And so the reason I'm focusing on this for some of you young scholars, graduate students, compound disasters is something that the federal government and many others are thinking quite a bit about today. So compound disasters can mean many things. It can mean, how do we deal with a hurricane in the midst of COVID when you have people evacuating to counties that had high COVID numbers, for example, or shelters where there are many people together? Well, another compound event could be, hurricane comes through Lake Charles, Louisiana, the devastation immediately that is associated with that, but then it knocks out power for a week or two in the middle of the summer. And so now you have the heat stress issues. So that's another example of a compound issue, or a lack of water on top of that. And so we are actually going into these communities all across the Gulf. We just went into Houston, Texas recently. We'll be in Louisiana in a few weeks, and then in Alabama and Mississippi. And we're trying to understand all of the factors that are associated with these compound type events and how they disproportionately affect certain communities, people within communities, infrastructure, and so forth. So I hope that, this discussion today, and I want to leave time for ample questions. I hope that this discussion today has provided some context for you in terms of where we stand on extreme weather events within the context of climate change, but also the realities of risk, vulnerability, and adaptive capacity. But then I don't, again, want to leave you with this idea of despair. I think that we have the solution space. We really do. On climate change, we know what we need to do for mitigation and adaptation. It's not a mystery to us. We just have to act. I firmly believe that we need a focused effort on climate change in the same way we had a focused effort to get to the moon, or we had a focused effort to develop the atomic bomb, or we had a focused effort, Operation Warp Speed, to develop vaccines to fight COVID. We need that same level of effort for climate, not just piecemeal solutions in universities or at think tanks or within specific agencies. We need a fundamentally coordinated effort on this topic. And then I think we can start to address some of those issues, but we also need to address the wealth inequality, because that's still going to lead to the weather climate gap as well. So that's my take on the extreme weather climate gap. I'm interested in your take as you start to ask me questions about it. So thank you.
All right. Thank you very much, Marshall. We have plenty of time. We've got 92 people on the call, so we should have plenty of questions.
Yes, to me, the questions are far more interesting. That's why I like to leave enough time.
I see that Ben had his hand up. Ben, did you have a question, or were you clapping? Maybe clapping.
I see a question from Steve. Oh, Steve has one. I'll go ahead and take Steve's.
Good afternoon. Nice to see you, Marshall. Thank you so much for your presentation today and for your virtual visit to the Ohio State University. Really appreciate it. And my question's about, you are a person who's been extremely successful in bridging that gap between the outside the academy and inside the academy. So translating knowledge and information through your work with the Weather Channel and your large Twitter following and all of those kinds of things. So for those of us who are sort of less successful or less experienced in bridging the gap, and especially for students and graduate students, as we're kind of moving maybe into a new phase of academics where there's more value placed on those kinds of engagements, can you give some recommendations or suggestions for how students and your colleagues here can get better established in that way?
Yeah, thank you for that question, Steve. And we actually had a little of that discussion with some of the smaller group of graduate students earlier. So a couple of things, I came from NASA, and I was talking with Ellen because I know she came from a different world before she came into academia as well. I spent the first 12 years of my career at NASA. And so in that space, NASA is a very savvy agency when it comes to sort of outward facing science. I mean, it does really good science and technology and engineering, but it has a TV station and it offers its scientists media training and so forth. And so when I entered the world of academia, I entered it with this perspective that I am not going to go in and be a card carrying academic. I'm going to, in some ways, be the anti-academic. While I understand the value and importance of writing proposals and publishing papers, I lead my department many years, including this one, in those metrics. So my point in saying is that is not to brag. My point is that you can be effective in doing those things and still tweet and still write a Forbes article and still host a podcast. In fact, I feel we must do it. I told one student, my metric of success will be when a colleague doesn't come up to me and say, how do you do all that extra stuff? Because to me, it's not extra stuff. It's inherently a part of my scholarly portfolio. It really is. And so I've talked about training my students to be end-to-end scientists. I want them to be able to write good proposals and publish in the peer-reviewed literature and so forth, but I also want them to be able to testify before Congress or not be scared off by the media when they reach out to them as well. So I think it's fundamental to our survival. And as I was saying to the students earlier, one of the things that brought me most joy, like I've been gotten all kind of awards, and it really is an honor to be elected to the National Academies of Engineering and Science. But what was most heartening to me was not so much being elected to 3 National Academies in 2021, but one of the citations actually said for his pioneering research in urban hydrometeorological research, or whatever it said, and moving the needle forward on fundamentally reshaping scholarship into the beyond the academy. That was an accomplishment for me because I literally wanted to come in and shake up the game. And I think we also have to see an institutional change as well. And we actually are starting to see that. There's something going on right now at the University of Georgia, Franklin College of Arts and Sciences, which is my home college. They are assessing faculty's service scholarship now. There are actually efforts ongoing to quantify that and to understand it and to develop ways to sort of integrate it into more of how we sort of evaluate and value its scientists. And I think that's a strong step forward. So, at the time that I got into the science, we're not too far off. I'm a little older than you, but there were some that still viewed public intellectuals and public scholarship as popularizing and not serious scholarship. But I would challenge anyone to look at my scholarly record. I'll stack it up against anyone's, right? But I'll stack up my tweets too.
Great, thank you.
Oh, I see a question in the chat box, and then I see a hand up from Josh. So I don't know how you want to handle that. So it says, I'll read the one in the chat and then I'll maybe go to Josh. Can you please speak a little more about thermal justice? It looked like a technical engineered solution to a social. We're keen to hear. Yeah, I mean, we're waiting to hear about whether we're going to get funded to do that. We weren't successful in the first round of the ERCs at NSF. So I'll tell you how that project evolved. It actually evolved. There's a mechanical engineering professor at Georgia Tech that reached out to me. He said, I reached out to you because someone said you're really one of the world's top experts in urban climate. He said, and I've been funded by Google and Apple and Yahoo for years to remove excess heat from their server farms, these large buildings with computers. He said, could we do that at the scale of a city? And I said, well, let's think about it. So we wrote a proposal and got some money from NSF, like a planning grant, to just think about it. And we realized we could probably do it, but we just need to think about it some. And so we were able to sort of produce what you see. I think you wrote, it looks like a technical engineered solution to a social spatial problem. And in a sense it is. We have some really innovative solutions. So for example, in this very laptop that I'm speaking to you on, there's a heat pipe, and that heat pipe redistributes heat away from some of the sensitive electrical transistors. Well, there's some engineering concepts we think we could do on a larger scale that actually accomplishes that same goal for a city and can redistribute that heat away from some of those racialized urban heat islands, for example. So right now, a lot of it is ideas on paper, but vetted and tested. If we can get somebody to give us $25 million, we think we can do it. So that's really the next step. So Josh.
Yeah, Josh?
Yeah, so a big part of your presentation talked about racial and economic inequalities.
Yeah.
And, this is pretty much built into the American political economy. And how, how should we even approach these issues? You know, we live in a very polarizing time in our nation's political history. And it almost seems easy to want to give up on a federal level. Like, are we looking at this from a local and state perspective mainly, or should we still continue at a federal level to address these issues?
No, this is a really great point. So one thing that I don't know how many of you are aware of, some of you probably are, at least right now in the federal system, there's a new initiative called the Justice 40 Initiative. I don't know how many of you are familiar with it, but in the current administration, within the agencies, there is an initiative called Justice 40 that says that 40% of funding or 40% of a larger programs have to be dedicated to sort of dealing with environmental justice and related issues, or justice issues that sort of are baked into the system, as you just correctly noted. And so I think there's reason to be hopeful about the role that the federal system can play. But the problem, as you I think also are articulating, the federal strategies are at the whims of the political cycle. And so on 2 to 4 year cycles, how much can we get done? So in that regard, I think it does require more local and state action, also more action by private foundations, companies, and so forth. And so we can move the needle in those regards. So here in the state of Georgia, we stood up something through funding from the Ray C. Anderson Foundation called the Georgia Climate Project. And it's a consortium of University of Georgia, Emory, and Georgia Tech. And it's a framework for addressing climate justice and other related issues that is independent of any particular one funding model. I think one of my big sort of messages to the academy is, and I've been trying to practice what I preach, is we have to wean and it's hard, but we have to somewhat wean ourselves off of dependence of federal funding completely for some of these challenges. But I will say that right now, I mean, if you're not familiar with the Justice 40 initiative, definitely take a look at it and Google it. I'll give you another example. I just submitted a notice of intent to a NASA research call last week. Earth Science has had a call on environmental justice, and I think it's a part of their Justice 40 checking the box, if you will. So, we have some interesting work we're doing at the intersection of extreme rainfall and hydrometeorological processes and septic systems and failures and how they affect disadvantaged communities. So this is the very reason I was attracted to the University of Georgia's geography department, or sort of even though my degrees aren't inherently in geography, but at the time that I was leaving NASA, I was actually being wooed, if you will, by some fairly traditional large atmospheric sciences programs, meteorology programs. But increasingly, I saw my scholarship, colliding with environmental justice and risk and spatial and temporal distributions and so forth. It wasn't just the Clausius-Clapeyron equation and QG theory. So that's why I was telling some of the students earlier, even though I'm a proud Florida State Seminole with 3 degrees, I'm headed to Florida State in the morning down to Tallahassee to the football game. Very much appreciative of my degrees from there. It's probably one of the top meteorology programs in the country. But it's not where I think we need to be. I think programs like ours at Georgia and yours at Ohio State is how we need to be framing ourselves these days.
Thank you.
Marshall, could I ask a question?
Yes, go ahead, man.
Kendra McSweeney, a colleague, and we were talking just 2 days ago with a colleague in political science and about the relative ease with which climate questions are demoted in today's sort of electoral environment. So, I was struck when you were talking, you were pointing to communities of color, kids, effectively senior citizens, and people living in poverty. 42% of the United States is not a non-Hispanic white. 22% of the United States is a kid. 16% of the United States is a senior citizen. And depending on the metric, 12% of the United States are living in poverty, but that's probably a radical undercount.
I think that's undercounted, yep.
So at any rate, these are large numbers of people, and yet climate justice is something which, at least right now, is not resonating in the electoral arena and has been demoted with respect to other issues. I was just wondering if you could talk about that with respect to the weather climate gap and this sort of lack of this inattention to the way people are experiencing things.
Yeah, that's a really good question. And I think part of the answer, man, is something that I alluded to earlier in the small group. I think James, from a political perspective, and I try to stay in sort of apolitical in terms of my discussions, because I do interact with both sides of the aisle, but clearly understand that there are political challenges. But I think James Carville said something that I think people forget. And I'm seeing it here in our own elections here in Georgia this cycle, as people are talking about all types of issues. James Carville said something way back in the Clinton election. He said, it's the economy, stupid. And as much as we want it to be about other things, people tend to vote on the economy. And I think politicians know that. So here's the strategy, though. Everything that I just said about climate justice has an economic component, but we don't frame it that way. And so we still want to frame it from our lens as opposed to the sort of co-producing that lens from the perspective of the electorate. I think that's one of the big problems I'm going to sort of make an analogy, then I'm going to come back to that point. When I was at NASA, I was the deputy project scientist for the GPM mission, the Global Precipitation Mission. And we had a workshop and we brought in water resources managers. We brought in agricultural experts and everything. And we said, here's how you should use this really cool 3-hourly global precipitation product. We're NASA. Do what we say, because we got that big, pretty blue logo and all. We're NASA. But the people at that conference and workshop said, look, all we want is GIS shape files. You're giving us these fancy NetCDF files and HDF. We can't even use your data, fancy NASA. And so what I learned from that is, we were coming at it from our perspective as NASA. And so when I think about this extreme weather climate gap and how we frame it, we don't frame it in a way that the policymakers know they can resonate with their voter base. And at the end of the day, I mean, I talked when I was briefing Congress in 2019, I talked about some of those very issues because, I want you to be concerned about the fact that historical redlining produced a situation where some of my wife's relatives that live in Southwest Atlanta are living in the hottest part of Atlanta's heat island. I want you to fundamentally be concerned about that. I do. But the reality is you're not concerned about that. You're concerned about whether that person has a job and their economic, but I can make a connection to that if I think about it carefully. So this is why I think in terms of our interdisciplinary or transdisciplinary scholarship, we have to frame narratives around not just the sort of issues that matter from it's just the right thing or it's just injustice. Those are important, but we've got to be more strategic as scholars. I think it's a struggle because I consider myself a pragmatist, and I think I probably do butt heads at time with some in the academy, even my own institution, because I find in many cases academics tend to be idealists. They tend to be very sort of, this is what we know is the right and wrong to do, and I resonate with that too. But I tend to also think very strategically about it. So I don't know if that really answers your question, but I think the answer's somewhere in there. I do. Renata and then Emma.
So, hi, Dr. Shepard. Thank you for the lecture. I'm a research scholar here at OSU. And I work to protect the power systems from climate change. But like,
you
as
work
you,
with Steve?
sorry?
Oh, so do you work with Steve?
No, I work with Professor Guzin, is from another department.
Yes. I see.
And as you showed in your graphs, the distribution is shifting, the climate distribution is shifting, but also like we are observing that, like I'm beginning in this field, but we are observing that in the rainfall scenarios, the the drier scenarios, they are becoming more probable. So there is a weight in the scenarios that we don't like, that are the ones that we don't observe rain, and these can impact the hydropower generation. So did you observe something like that, or can you comment on the rainfall scenarios due to climate change and the difference on trend?
In the difference, sorry, I don't know if I understood the last part, what you said, but I think you're asking about just changes in rainfall distributions.
Yes,
Because
yes, exactly.
one of the things that we've always known, yeah, I don't, I often, I see the question about the slide deck. It's a pretty large slide deck, so I generally don't share it, but I can see if there's ways I can get you something, if there's something you're interested in. But yeah, one of the things that we've always known is the driest places are getting drier and the wetter places are becoming wetter. That was what climate scientists always knew would happen. So we're starting to see that. But one of the things that I want to warn people about when we're talking about rainfall, because it's confusing the policymakers and stakeholders, and also other parts of climate as well, don't strictly talk about amount, because then you'll have people who say, well, it's getting drier where I live, or it's the rate of change that's the real concern in many of these processes. It's the intensity change and the rate of change, the first derivative, the derivative, if you will. Because if you look at, say, where I live here in Atlanta, you might say, well, we've got less rain or we've got more rain, and it's not really within a large bound when you sort of look at it in the whole. But when you look at the intensities or the distribution of the heaviest rain events in that distribution, that's where the concern is. And so in general, the answer is drier places are getting drier, wetter places are becoming wetter, but the intensity changes and the frequency intensity of drought currents are the time component of those changes are what are most concerning in terms of the societal impacts. And I also wanted to address a question. I just put in the chat. There's a question about indoor thermal justice. I don't really look at that, but my former student, Mariana Fragomeni at UConn, has done some work in this area of indoor thermal justice. It's certainly a part of the conversation. Emma.
Yes, hi, thank you so much. Just for some brief context, I'm currently in Dr. EMT's global climate change class, and we're beginning to work on our final papers. And my topic for that paper is really focusing on the climate change denial industry and how these sort of misinformed and ignorant ideas were founded, and then the factors that have allowed them to be perpetuated, especially over the past decade to 20 years. And you mentioned something that really stood out to me, the idea that we need people to be making active strides to better our environmental circumstances. We need to be putting the same effort that was put into working towards a COVID-19 vaccine towards this effort. So my question is, do you think that the reason why scientists have experienced difficulty in accomplishing these goals has to do with the prevalence of the denial industry? Because to me, it seems like scientists and climatologists have had to waste their time re-explaining the same phenomena and the same data to skeptics to prove something that really we already know to be fact, that the climate is changing largely due to anthropogenic causes and we need to act now. So do you think that that is something that is a relevant challenge to the scientific community?
I think the scientific community is part of the problem.
Okay.
Boom. You weren't expecting that. So that's why I wrote this article, 9 tips for communicating science to non-scientists. Scientists have spent a lot of time communicating, but we've been spending a lot of time, in many cases, not everyone, communicating in our own jargon and from our own perspectives, and that people don't resonate with. And so that's why it's been hard. But having said that, absolutely, the denial industry, the sort of merchants of doubt crowd that you probably are referring to, have sort of fundamentally undermined our efforts for decades. But I think it's sort of their influence is weakening. One of the things that you see it in the Yale climate communication. You see it in the demise of these various think tanks that used to be out there pumping out things like the non-governmental interpanel on government climate change or booklet and so forth. You're seeing those types of things wane. But yes, Upton Sinclair said something very profound when he made the point, excuse me, that it's difficult to get a man to understand something when his salary depends on him not understanding it. If you think about what Upton Sinclair is saying there, that is the underlying sort of root of much of the sort of contrarian machine that was in place for the last 30, 40 years. But again, I think those are almost relics now. I think we've moved beyond that. Where we are now and what we talked about at the White House a few months ago is how do we move beyond the climate delayism phase? I mean, it's interesting because whenever I give these talks, there's still a lot of questions that come up about the denialists and the skeptics. And the world that I operate in, and I operate at the sort of local level all the way to the Congress, I don't feel that much anymore on either side. I mean, you hear it because that 7% is the loudest on Twitter or at Thanksgiving dinner, that uncle that's watching some YouTube and telling you his theory. But it's not, I don't feel the weight of that anymore. And I'm pretty much in these circles. So I think we as scholars got to move beyond it too, and just start understanding and focusing on the solution space and start focusing on sort of how we sort of articulate the economics and move us beyond we know what we need to do, but how can we pay for it, and how can we do it in an equitable way that's not on the backs of marginalized communities, poor people, and so forth. That's where we need to focus our energies, not sort of swatting flies on Twitter and so forth. I really believe that. So, and I'll give the media is complicit in this to some degree, not at all. I don't like to use these absolute terms. But for example, I'm one of the scientists that gets quoted a lot whenever there are extreme weather events. And I tell them flat out anymore, I'm not commenting on your story if you're going to send me an email asking me to comment on what I think about it being the warmest summer or the second warmest winter or the third. That to me is not news anymore. It is what it is. So now we've got to really talk about the sort of intersectionalities of what those things mean for economics, health, and society, water supply, and so forth. So
that's great. Thank you so much.
I see Aaron pop up, and Ellen, you just tell me when to stop. So, because I'll answer our questions all day. So,
I think you were muted, Ellen. Sorry.
We have about 20 minutes.
Okay, yeah, I'm good to go. I mean, like I said, I'll take questions on anything that you heard me say, whether it's about career, as Steve talked about, or these issues I talked about in the talk. I mean, I'm yours for the next 20 minutes. I have nowhere to be and no one's at home. My kids are taken care of. So go ahead, Aaron.
Yeah, so thank you, Dr. Shepard, again for your presentation and engagement today. I'm a product of the Atmospheric Sciences Department here, and now I'm an Ag, Weather, and Climate Field Specialist with Extension here at OSU. And so I spend a lot of time engaging the farmers and the agricultural community, and your message always resonates really well. One of the things that I've been thinking about quite often, and I think it fits this gap idea, and I want to get your thoughts on it. Even some of the metrics that we use to convey those impacts, like billion-dollar weather and climate-related disasters, I think miss the mark, right? If you got a farmer that has 6 inches of rain in 2 hours on their field, and they lose their crop, and they lose their nutrients, and it ends up water quality and things like that, that largely goes unreported, unaccounted for. And in the Midwest, since the face of our climate change are really these heavy downpours, these extreme events, we don't have a good accounting method for taking that into consideration. And I'm wondering if there's any thoughts, discussion at the national level, the academies level about that, or in other realms of being able to account for that a little bit more. I know a lot of the insurance data, we can do that, but it's not readily available. And so some of the colleagues that I work with, we're thinking really closely about this concept that how do we really convey what's happening to these very small localized area that you're not going to hit $1 billion for, but is equally, if not more, disastrous for those folks that live there.
Yeah, Aaron, I think you're spot on with that. And by the way, I don't know if you know Pam Knox here at the University of Georgia, but she's certainly likely one of your colleagues. You're spot on. And that's really the kind of point I was making in response to Matthew's question earlier as well. We've got farmers lose all of the time as it relates to rain or drought, but it may not rise to these sort of large gaudy metrics that we often use. But yet, if you sort of develop a metric that sort of empathizes with them, an empathy metric, if you will, and what I mean by that is a metric that resonates with what they are dealing with. Then you start to build political capital with that group of people that, historically, in some cases, the farmer community has, in some cases, skewed somewhat skeptical, at least here in the South. I imagine it may be that way there as well. And so that's exactly what I'm talking about, because they're never going to go to the NOAA NCEI website and look at sort of the $1 billion metric stratification and so forth. I know I lost my peanut crop this year, and that impacted my family and 10 families around me. We saw a little of that in Georgia. I'll give you an example. After Hurricane Michael in 2018, it destroyed much of the breadbasket of the state of Georgia's crops. I got a call. I'm sitting in my office at the University of Georgia, and the Agriculture Commissioner of Georgia calls me. Well, out of nowhere, literally out of nowhere. And this is someone that probably 5 years ago would not have called me at all about climate. And so he understood that many of the farmers in this state lost their peanut crops that year. And yeah, probably, in that sense, when you add up all the economic damage, it probably totaled $1 billion. But to any individual peanut farmer in Plains, Georgia, or Albany, Georgia, it may have been it may have been sort of a year annual income, but that was impactful. And yet we don't report it or sort of use those narratives. And I think I don't have the answer, but I think you're spot on. I hope you and your colleagues will continue down that road. Andrew George asked if I have any advice on getting employment with NASA. That's a pretty big question because NASA has so many different areas, but I'm assuming you mean in maybe earth sciences. I'll give you a little bit of background. Most NASA centers have a specialty area. There are 10 NASA Space Centers. Most of the earth sciences work at NASA is done at either Goddard Space Flight Center, a little bit at Marshall Space Flight Center, a little bit at JPL as well, and a little bit at NASA Langley as well. At NASA Goddard Space Flight Center, there are 12,000 people on the center. About 2,000 of us, or maybe more, I don't know, were civil servants, actually worked for NASA. The large majority were actually federal contractors, and that tends to be often is a way in the door to work for what they call, at least in the federal sector and the DC area, one of the Beltway bandits. They're typically jobs as coders or support scientists and so forth. And you're not usually going to walk in the door as a card-carrying civil servant NASA scientist. You're usually going to backdoor your way in through one of these companies, or NASA and NOAA and DOE and others have postdoctoral programs as well. So those are typically the pathways in. You can get jobs at master's levels, but you need to have a good degree of coding experience and so forth, and you'll typically be in a support scientist role. To be a PI level scientist, you really need to have that doctoral degree. Okay, so there's a question that someone's been thinking about the vulnerability map. I guess I showed from our 2021 paper. Thinking about the map you showed, what is the role of personal experience and engagement with climate change issues, Nancy? Yeah, well, there's data that I've seen in the peer-reviewed literature, Nancy, that suggests that people's perception shifts on climate change when they experience an event, a climate event, whether it be their house floods, they lose property in a hurricane and so forth. So, or wildfires, So there is scholarly evidence that, as I was telling someone earlier today, for the average citizen public, everything's local. Either if it's happening around them or on timescales that they feel that they are impacted by, then they perceive more impact. That's why the pandemic was such a different beast than climate change. People saw people dying around them or people getting sick. And so there was more of a sense of urgency ultimately than climate change, which is happening around us and impacting them, but there's not a perception that it's impacting them locally or immediately. So. Do you feel that the media has challenges reporting on climate in a way that understanding? Yeah, I think they're getting better. You don't see this sort of false narrative, false equivalency stuff you used to see in the media where they got to report, quote unquote, report both sides. I mean, that used to be something that was a big problem in the media, but I think we've gotten past that. I still think they're too focused on like, oh, that's the strongest hurricane ever, or this is the warmest year ever. Yeah, that's not news anymore. That's just going to happen. I think they're still struggling to find the narratives that connect these points to the so what and kitchen table issues of people's lives. I think there's still struggles there. One of the things that I would point you to here in the state of Georgia, we published have a website called the Georgia Climate Stories. And that was something that was produced by that Georgia Climate Project that I mentioned earlier. One of our journalism professors at Georgia worked with some production companies. If you go to that website, there are these little stories. You can click on the Georgia map and there are stories that pop up that talk, they're little short narratives on how climate change has even impacted a blueberry farmer in Georgia, or water resources along the Chattahoochee River, or how solutions or how a battery farm in Commerce, EV battery farm is changing the economy in that small rural community. So we feel that storytelling is a big part of the climate narrative that is underutilized. And so if you want to sort of see some really good examples of that, check out that Georgia Climate Stories website. Could you give your general thoughts on, my general thoughts on geoengineering? I mean, again, I don't know why I don't know why we jumped there. We know what we need to do in the mitigation and adaptation space. I guess to me, geoengineering is like using a Ferrari to run to the into my neighborhood to pick up my son from the bus. I mean, it's just kind of an overvalued problem right now. Yeah, no, we need to have it in the stable as a solution space. But I'm of the age that some of you are listening to be, that you will know the group, the Pet Shop Boys, which is an 80s alternative group. They have a song called "Sometimes the Solution is Worse Than the Problem." Now, I don't know that geoengineering solutions are worse than the problem, but I do know that the atmosphere is a nonlinear system. And so, while we may know that there's certain things that will happen because of some of the geoengineering strategies, there's some things we still are trying to understand as well. Plus, there are the ethical issues involved as well. So, am I completely dismissive of geoengineering? Absolutely not. But do I think we need to go there right now? No, we know what we need to do, and it's within reach. We just have to have the will to do it, technologically, policy-wise, and otherwise. Mark.
Well, hello, Professor Shepard. I met you once down at Georgia when Dave Parinci invited me to give a talk.
Yeah. Oh, yeah. I thought you looked familiar. Yep.
Yeah. Well, but it's been really great to have you, and thank you so much for your really inspiring talk, but also for the way that you just expressed what has been resonating with a lot of us in terms of climate justice. And I think personally, one of the ways we need to remove the politicized terms is just talk about justice. I mean, justice is justice. Injustice is injustice. And I'm, let's just be a little hypothetical, although somewhat practical as well. I like your pragmatism, because I think we just need to be more engaged civically. And one of the big problems is people are checking out, right? We're checking out in wholesale ways. And really, I think the strength of our democracy is not that we can collectively think better with big numbers, but actually that we bear the consequences of our decisions together, regardless of what they are. So whether we like it or not. So I like the way you're sort of bridging that gap too, and speaking pragmatically. But I'm just curious, as we think as geographers, right, that unify us all, how do we practically revise some of the way we're teaching? I mean, we talked a little bit about the way students might prepare for a career and the way we might better communicate stuff. But I'm concerned about my craft. I'm concerned about teaching, and I'm concerned about where my students are in a realm of such severe injustice. But also, we just had our climate research symposium at the Byrd Center, and we featured two keynotes, one on injustice and the other on mental health. And there's a lot of struggles here when we come to grips with what we're facing. So yeah, how about it? I love the way you said you're sticking to Georgia because it's where you feel you can really make inroads on a lot of fronts. But anyway, yeah.
Well, yeah, and I don't just stick to Georgia. I think we're doing some things very specific to Georgia, but I definitely foray at the national level. But a couple of points that with your excellent comments. I'm really good friends with Congressman Bob Inglis from South Carolina, who's a card-carrying conservative. He will brag about his A+ conservative rating, but Bob also is a climate hawk. He's very active in the climate space. And he and I are co-chairing a committee for the American Academy of Sciences And one of the things that Bob says is, we know it resonates with your point. We know there are justice issues, but as soon as you throw out environmental and climate justice, you immediately turn off a certain segment of the political spectrum. And no matter how much you hit them over the head with it, they're going to tune out when you use that wording. So I think there's something in what Bob's saying for all of us. We have to, we get engaged and we're passionate about what we believe in these things, but fundamentally somewhere else believes something fundamentally different. And so you're not going to change them any more than they're going to change them with your hammer approach. You have to have a more nuanced approach. So I agree with that. On your how we educate, we're having this very discussion right now in our department. We're the Department of Geography right now. Whether we will be that next year, I don't know. I'm leading a committee thinking about that because we want to one of the things we are fundamentally trying to shatter, and we had a faculty retreat here recently at Georgia, led by our department head, Hilda Kurtz. We hate the human geographer, tech GIS, physical geography silo framing of how geography departments are organized. And we are fundamentally and radically trying to shatter them in our department right now. And so we're actually going through an exercise right now, looking at the name of our department, looking at various focal areas, and even the types of degrees that we offer within geography. Right now, we have 3 degrees. We have an AB in geography, a BS in geography, and a BS in atmospheric sciences. We think that doesn't represent fundamentally what the sort of broad notion of what students want to be, and frankly, what may attract the curious student that doesn't have a clear understanding of what we as geographers do. And so, it's a question that if you come back to me in 6 months, I might have a better answer for you, but it's an exercise we're actually going through ourselves here at the university in our department.
Thank you.
I hear I made history there. Thanks, Matthew. Let's see. I think that's the only thing that I'm seeing in the chat right now.
Yeah, I don't know who put this, I guess, was that Alex, who said you might be interested in OSU's EEDS degree?
Yeah, what does EEDS stand for?
Yeah, Alex, you still on?
Yeah, what does it stand for?
I think it's environmental, economic, and development, something or other.
Okay, so it's kind of one of these hybrid degrees, yeah.
Mm-hmm.
Yeah, no, I think we're just rethinking. I mean, we kind of came to this sort of organic conclusion in our faculty retreat over the spring, or the summer rather, that we just don't want to call ourselves physical geographers, human geographers, and GI science folks anymore, because that's too limiting.
Mm-hmm. Well, I've been in our department for a lot of years, and we've had similar discussions, and we've broken into different groups, and that doesn't quite work. And then we break into other groups, but
yeah, the name is not really that important. Yeah, the name is just strategic for undergraduate recruiting. Really, the importance is the degree. So, for example, we have an atmospheric sciences degree now at Georgia. We didn't when I got there 17 years ago. We just had a certificate. It was a 31-hour certificate, but because it had to meet AMS and National Weather Service credentials. So I was like, why don't we have that as a degree? But we finally got it to be a degree. But atmospheric sciences is not in our name, and it won't be in the name of anything that we might propose a change to. But within there, we have a degree. So, students like my daughter, who's a first-year student at UGA, when they look at certain things and understand what degrees you offer, I think we've just got to strategically think about the world that we're in now versus the world that, perhaps we were in 20 years ago. One of the things I find, again, I told you I'm a pragmatist. One of the things that I find is oftentimes, I don't know if this is the case at geography at Ohio State, and you don't have to admit it if it is, but one of the things that I find in our department is often colleagues tend to think about our program strictly from a graduate perspective only, from the research and graduate student perspective. And we're trying to attract undergraduate majors too, and they don't think about the things that we might be thinking about from a graduate and research perspective. And so we've just got to be able to walk and chew gum at the same time.
So it might be good if you have a committee that's discussing this, having some undergraduates on the committee.
Yeah. Oh, yeah. We've already. Yeah. I'm not saying too much right now, but we're well on down that road. So
Oh, okay.
I'm actually the chair of the overall committee thinking about some of these things.
Yeah.
But do you think that if someone asks if I find that young people today get it when understanding the entirety of the climate? I do. And I think it's apolitical. I see it on both sides of the political ledger, even if you talk to young Republicans or young Democrats on your campus or libertarians or whomever, I see some common threads. I think there's still some differences in terms of the solution space and so forth. But I think as a whole, I think people get it because, we used to talk about digital natives and digital immigrants. Like my mom is a digital immigrant, right? Or am I getting it right? She's a digital immigrant and my son is a digital native. In other words, my son, when he was 3 years old, he walked into an Apple store and he started swiping the screen because he thought it was a tablet. Right. Whereas my mom doesn't want anything but a flip phone. She's like being kind of dragging, screaming into this. I think this generation of students are digital, are climate environmental natives. So they grew up in AP environmental classes and they grew up sort of thinking about some of these things that, our generation perhaps didn't. So are there specific and pragmatic academic partnerships that you advocate for, whether in a general, again, the Georgia Climate Project, Drawdown Georgia. We have an ICON integrative conservation PhD program here at the University of Georgia that some of your students may be interested in. The program is called ICON. And that really kind of gets at some of these cross-narrative, cross-disciplinary challenges that I think this EEDS degree program, we have a sustainability certificate at the undergraduate level at the university where you can major in anything and then take a certain number of hours to get that certificate. We have an environmental ethics certificate at the University of Georgia as well that students can take and so forth. So those are just some of the things that come to mind, Claire. But I think every university of our size, whether it's Ohio State and Georgia, have these types of things. So we're not as big as you all. What is the student population at Ohio State these days?
What are undergraduate?
Yes.
What would you say? About 45,000?
Oh, maybe we are similar then. I thought you were much bigger.
It's been as high as like 55.
Okay, we're around 40, but I was thinking you all were closer to about 60 or 70.
Yeah, we'll get up there if we add our professional schools.
Okay, Donnie Hoover says it's closer to 60, which is kind of what I thought as well. Well, maybe I'm thinking about the overall total population and not just undergrad. So,
well, our department has been discussing different certificates, and I think we just had one approved.
Well, we already
right, Matt?
We have a GIS certificate already, and we had the atmospheric sciences certificate before it became the atmospheric sciences bachelor's degree. So yeah, we're looking at some professional certificates and other types of things right now as well. I think it's all a numbers game, in that we're trying to sort of grow in undergraduate majors and so forth. I imagine you all have similar interests and challenges. So
yeah. Well, I just had, we have 5 minutes total to get to 5 o'clock, which is our absolute stopping point.
So let's see. I'm a healthcare provider and I'm interested in whether you've interacted with Yeah, sure. I just gave a talk at the State of Public Health Conference yesterday at the University of Georgia to answer Sue's question about, so yeah, we certainly interact. That was put on by our School of Public Health. Obviously, being here in Georgia, the CDC is in Atlanta, so we interact with them quite often on some of the work through the Georgia Climate Project. What is the most surprising? This is a good one to end the talk, maybe end the discussion on from Ben. What is the most surprising thing you've learned while talking to the wide variety of people on Weather Geeks? That's interesting. Interesting conversation I had, and maybe it was because I was fanboying a little bit. We had things that were on the show. The TV show is my favorite, not alternative. Just hearing some of the ways that better in nature writing. Those of you who don't look on this boat, you're too young, you probably really experts on new science. Last time so
Marshall, the last comment was coming across really very slowly, like the transmission is intermittent.
Yeah, I think my battery's dying in my laptop. So.
Oh, we've worn it out.
Yeah, I have it plugged in though, so I don't know why. I'm going to turn some things down here.
Well, while you're working on that, I notice in the chat, we've been corrected on, we've got a bunch of different numbers here in terms of the number of students.
Okay, can you hear me?
Yes.
Okay, I don't know why. No, I was just curious. Yeah, so 53,000 undergrad. Yeah, I thought it was you were much bigger than us. That was really my only point. Because we're only at about 30 something thousand in terms of undergrad population. So
I have maybe a final question.
uh-huh.
When you go out to speak with people, this is something that about climate change. We also give presentations to groups like the Rotary and just different organizations. And also we have a lot of interaction here at the Bird Center with schools and Boy Scouts, Girl Scouts, kind of the younger people. And I've heard a lot recently about concern about climate change anxiety.
Yes.
And the fact that a lot of the young people are very concerned. They feel that they're not empowered to make a difference. And yet the bad things, the bad outcomes will fall primarily on their generation. I think that's another area where climate change can interact, like with the healthcare professionals in terms of mental health.
Yeah, if on that graphic I showed earlier, one of those little boxes was definitely mental health issue challenges and support. And I think that, many of our younger segments of the population have expressed climate anxiety or climate exasperation, and that they just kind of give up, throw their hands up as well, or climate anxiety. I think those are certainly things that we see. Again, they sort of are and like many of the things that we talked about earlier, they're challenges in society, but do they raise to the level of concern for a policymaker or those making decisions? Probably not. So
yeah, I think
Thanks,
you're right.
Steve.
That's where we miss the boat.
Yeah.
Is not we get down in the weeds and worry about everything.
Yeah, I think you've got to be strategic, got to find the value system that resonates with the policymaker and go from there. And then hopefully then we can sort of get to all one of my sort of, and I'll end this with the one soapbox. Again, I love academia, by the way, but there's some things that I really don't like about it. And one of the things I don't like about it is when we're working on like big grants and things like that. I mean, we've got to involve them or they're going to feel left out. We've got to be strategic and be focused. In other words, in order for that to sort of be successful in some cases. So, because you can get down into the weeds of things and start to dilute the sort of key challenge or problem you're trying to address. But I think there's sort of all hands on deck. Everyone wants to feel involved sort of mentality. And again, part of that probably comes from my experience at NASA, being very mission focused and being very focused on the objective at hand, as opposed to worrying about whose feelings are hurt or who's not involved. So because I think you asked earlier, Ellen, in the grad student, what experiences I have from NASA, and so how does that sometimes resonate in academia? So.
Well, we're at 5 o'clock, so I'm going to be good to our word, and we're going to just thank Marshall for spending all this time with us and spending time with our students in the earlier session.
Thank you so much, and I really enjoyed it. And perhaps at some point I'll be able to. I still want to come to a game in the big house there. I'm a big football fan, so I hope to maybe visit there one day. So I'll perhaps see you again.
Well, we hope so.
Yes.
Thank you.
Bye.
Bye, thank you.
Thank you, Marshall.
Bye. Thank you.